Start.
Good morning, dear friends. This is Dr. Suhas Sabnis. I'm here to deliver a lecture on the model crystallography. The point that I'm engaging today is sodium chloride structure. So I'll write the name sodium chloride. It's a popular name. We all know, we all use it every day. It's a popular material. And it's a basic crystalline material. The point is, why should I have interest in sodium chloride? So that first point of focus is clear, then the basic understanding with the structure becomes more easy. Sodium chloride is one material which we use daily. So that's where for every crystallographer it is bound that he should know the details about this structure. This is point number one that I am stating here. That this is so common that it is common to know what sodium chloride is all about. This is point number one. Now, second, sodium chloride is general representative example towards ionic structures and their configurations. So, it is representative of ionic structures and ionic structural interactions. Okay? Why I say this? Because ionic structures act in a specific way. They do not act in the same way as other covalent structures act. So naturally, our interest is to know this representative example in terms of its structural configuration, detailing about it, and then how we can use this structure for understanding of other ionic structures as well. So basically, understanding sodium chloride structure, it is sodium chloride is nothing but Na plus and Cl minus. Okay, do you agree with this? It is sodium plus and Cl minus. So unit cell of sodium chloride is comprising of two ionic behaviors, sodium plus as cation behavior and chlorine minus as anion behavior. So if those two anions come together and form the structures, it is not Na and Cl which forms the sodium chloride structure, but in fact it is Na plus and Cl minus which actually forms a sodium chloride structure. Now why I am making it more clear, even if we know this, is because crystallographers must have an interest in the term geometric configurations of Na plus and Cl minus. So geometrically stating, what is the impact that Na plus is having in comparison with Na? That is what I am making it clear. It's very simple that Na is 281. Its electronic configuration of states we call it. It is 281 and it is nothing but the last shell is having one electron in it. So naturally its behavior is unstable. It wants to donate that electron, it wants to share that electron, and this sharing is a need for sodium. Then there is Cl minus, or we say Cl, which is 287. It has 17 number of electrons. So the last configurated state in chlorine is having 7 electron in its valence shell. So chlorine is ready to accept one more electron to complete its octet. So it is a need based behavior. One can say that this is ready to donate one electron. On the other side, this is ready to accept one electronic states. Then say one electron is donated, it is given out. Then what will be the net impact? The net impact is that Na plus is reduced to the configuration 28 in otherwise neutral state which was 281. So the same nucleus which was earlier attracting 2 plus 8 plus 1 means 11 number of electrons will now be attracting only 10 number of electrons. So what will be the net impact? Because of this, we find that force per electron, I am using a term, force per electron is increasing. So the nucleus will be offering more force, more screening onto the electrons, which are now reduced in the number by 1. So force per electron is increasing. It does mean that electrons in their configurated states are held tight. The electrons will be more attracted towards the nucleus, and finally what happens because of this is that the ionic radius of the Na plus, ionic radius of Na plus is less than otherwise found neutral sodium. So the neutral sodium in comparison with Na plus, the radii of Na plus is less than Na. Now coming back to the second, that is Cl minus, the chlorine is having 287 configurated state, ready to accept 1, say got 1, reduced its configurations from 287 to 288. The same chlorine configuration now reduces to Cl minus as 288, now has to attract how many electrons? It has to attract 2 plus 8 plus 8, it does mean that 8 plus 8, 16 plus 2, 18 number of electrons. So otherwise neutral chlorine was attracting 17 number of electrons. Now chlorine minus has to attract 18 number of electrons because of this particular change. So what will happen? The screening would reduce. The screening would reduce, force per electron will reduce. The force per electron reduces, it does mean that electrons will have more randomness, more freedom to enjoy. So naturally the shells would swell. Naturally they will try to apply more electrostatic force of repulsion on each other. That's where the ionic radii of Cl minus is a swelled state. It does mean that it is growing in terms of radius in comparison with the otherwise found neutral chlorine. So the two statements I make that here, that the ionic radii of Na plus is less than the otherwise found neutral sodium, and ionic radii of Cl minus is greater than the otherwise found neutral chlorine. Now these two states are coming to form one compounded ionic state, and this compounded ionic state is sodium chloride structure. I have drawn this structure in front of you, and I am into the interest of this particular structure going to discuss how the configuration of these particular Cl minus and Na plus is happening inside this particular structure. Just see, I have already drawn it to save your time. The chlorines are occupying the positions of corners and face centers. Corners and face centers, you can say these are also minus minus. Few representative examples we can draw, and the sodiums are occupying the positions of the edge centers and the body center. Once again I make it clear, chlorines are occupying the positions of corners and chlorines are occupying the positions of corners and the face centers, and Na plus are occupying the positions of edge center and body center. Something more to explain here. Now if you just see here, the contribution, if you call in the totality, the contribution of the states of Na plus and Cl minus, we have one atom which is Na plus at the body center, and you will find all the reference books giving you, citing you the reason that NaCl, so that sodium chloride structure is not a structure which is a BCC structure, it is a FCC structure. Now we need to clear this particular fact, that one particular cubic structure which does have one body center is not a body centered structure. Now this is made clear with the example of what is the nature of a body center or what is the use of a body center. In terms Body center defines center of mass. Body center defines the point where the entire mass of the body is supposed to be concentrated. And if we try to calculate in the same logic, is the mass of the entire sodium chloride cell concentrated at this Na plus? We find the result is negative. We find that this is not happening. It does mean that it is not definitely serving the purpose as a body center. Then what purpose it is serving? It is serving the purpose of charge balancing. Now how does this charge balancing is taking place? I'll just explain you the complex nature of the force that sodium chloride is exhibiting here. We just see Cl minus and minus at also the phase center. It does mean that corners are repelling the phase centers. My first statement, corners are repelling the phase centers. Phase centers are repelling each other. Phase centers are repelling each other. Body center is attracting the phase center. Then corners are repelling each other. But the edge center is attracting the corners. The body center is attracting the corners, but the body center is rejecting or repelling the edge centers. See the complex nature of the force that this small cubic cell is exhibiting in front of you. So the nature of the complexity of this force makes too many negative forces and too many positive forces to happen inside the sodium chloride structure, which needs to be neutralized. So what do I mean by neutralize? It does mean that all positive forces and all negative forces that happen to be here, if the vector sum of all attractive and negative forces comes about to be equal to 0, then we say that the charge balancing is being done, and if the charge balancing is done, then sodium chloride becomes a stable structure. Okay, so with that particular aspect we need to take this particular discussion ahead now and just see whether the charge balancing is achieved inside this structure or not. Okay, let us see this. Now contribution of the sodium plus we will find. Contribution of sodium plus. Just see here how many atoms are or ions are present for sodium plus inside one cubic cell. See this, the sodium plus is completely there at the body center, so I can there say that our rule is very clear. This is number of corners divided by 8, because contribution will be divided by 8. Each corner divides the volume into the 8 structures, neighboring structures. Then NB body center by 1, then phase center by 2, and finally one more thing, that is edge center, we will call it an ED by 4. Each edge center contributes 1/4 of its own volume to each unit cell. Okay, it is just like taking an apple and exactly cutting it into the 4 halves, okay, vertically. So if I am taking first section will give me 1/2, and for that half itself if I take another section of this, I'll get 2 halves of this. Okay, so naturally it is just like taking an apple, taking a horizontal cut and then taking a vertical cut of that same apple. So whatever you will find will be the 1/4 part of it, just attach it here. So that is the contribution of this particular Na plus. So naturally how many number of corner contributions are here? Corners do not belong to Na, so it is 0 by 8. Body center does belong to Na plus, so it is 1 by 1. Phase centers do not belong to Na plus, so it is 0 by 2. And edge centers do belong to Na plus, and these are 12 in number, 4 in the bottom, 4 vertical, 4 at the top. So 4 plus 4 plus 4 is 12, so it is 12 by 4. So it will be 0 plus 1 plus 0 plus 3, so it will be 4. So contribution of Na plus in that sense becomes equal to 4. Now we'll be going for the contribution of Cl minus. If we try to calculate the contribution of Cl minus in the same way, that is Nc by 8 plus Nb by 1 plus Nf by 2 plus Ned by 4, then we'll find that the corners do belong to Cl minus, so we'll have 8 by 8. Body center does not belong to it, so it is 0 by 1. phase centers do belong to it, so we will have phase center 6 by 2, and it doesn't belong, the edge centers do not belong to Cl, this Cl minus, so 0 by 4. So I get 1 plus 0 plus 3 plus 0, in that sense 4. So 4 as to the previous, if you find it is 4. So 4 as to 4, it does mean that it gives you 0. So it does achieve a charge balancing. So presence of Na plus, analytically it is being proved here that presence of Na plus at the body center serves as a charge balancing center rather than a center which is a body center, okay, or center of gravity or center of mass for that particular NaCl cell. Now we'll go to certain calculations. Certain calculations, it does mean I'm moving here towards the calculation of atomic packing factor. We'll call that as ionic packing factor. So before that, just look at this particular edge. If we just look at this edge, this is Cl minus, and then we have one Na plus here, and then another Cl minus. So the edge calculation does state that if the entire distance is called as A, now this we will be calling as R minus, and this will be entirely, because it is the entire diametric distance, so it will become 2R plus, and this distance again will be R minus. So I will be having a distance R minus plus 2R plus R minus will be equal to A. It does mean that 2R minus plus 2R plus is equal to A. It does mean that R minus plus R plus 2 is equal to A. Okay, we'll require this particular thing at some point of time. Now going to the calculations of ionic packing factor, of course the ionic packing due to the Cls and ionic packing due to the Na plus has to be calculated separately and then added together. Okay, we cannot conjugately add them together to calculate it. So this ionic packing factor will be nothing but 4 by 3 pi R cube, I'll call it as R plus cube, into N, okay, divided by A cube, and then 4 by 3 pi R minus cube into N, okay, divided by A cube. So I get this A is also common, so I get 4 by 3 pi, this is, and N is also common, R plus cube plus R minus cube, okay, and this divided by A cube. Okay, what is A? I am substituting the value of A over here, so it will be 4 by 3 pi. Now N is nothing but the number of molecules. I'll call it here number of molecules. I do not call it 4 plus 4 as 8, but I need to substitute this as 4 molecules per unit cell for sodium chloride structure. So it is 4 into R plus cube plus R minus cube divided by the value of A is A cube here. So it is 2 cube, that is 8, and R minus plus R plus cube. R minus plus R plus cube. Now further to this, let us put the values. If I put the values, I am removing the structure now. It is already known to you. You just need to calculate. The analytical sense is remaining. Just see here. So 4 by 3 pi into 4. Now I will put the value of R plus as 0.98. So this is 0.98 cube plus this is 1.81 cube. Now this is divided by 8. R minus is 1.81 plus 0.98 and cube of this. Assuming that we can take the common factor of 10 raised to minus 8 or minus 10, it will get cancelled. We can directly write these values. And if we solve all this, I am not going into the details of these calculations, it can always be done. Analytical sense is very easy here, it is not very difficult. So we get 0.66. Okay, so we calculate it as 0.66. It does mean ionic packing factor for sodium chloride structure is 0.66, white space is 0.34. It does mean 66% of the volume is occupied by the ionic states and 34% of the volume is void. Okay. So this is something it is expected in the exam, that you start with the description of sodium chloride structure, then finally come to the conclusion about the position of Na plus first as the charge balancing center, and finally conclude on the ionic packing factor of 66% and void as 34%. You will get full marks for this. I hope you understood this. Dears, thank you. Thanks a lot.